dot here, okay, that indicates that the recording is going on. So if you don't see that at some point, you might notice it before I do, so let me know so I can restart the recording process. Okay. The sooner we do that, the less of a gap there'll be. Okay, numeric variables, arguments, and parameters. So, all this data that you store in classes and objects ultimately has to be stored as numbers. Those numbers are called primitives. Okay, they're not objects, they're just simple numbers with a fixed amount of memory allocated to them. And there are a lot of different ways you can store these numbers. You can store them as integers, you can store them as floating points. That's numbers with a decimal point and something afterward. You can have a range of values using 8, 16, 32, or 64 bits. Larger bits means you can hold a larger range of numbers. And there's even one for true-false. So, all these different formats, obviously they're good for a lot of things. Number one, smaller memory requirements, right? If you are using just small numbers, you don't need to use the really big number types, and you can save a lot of memory that way. Holding larger values. If you have large, complex, if you want to hold out a number to 10 decimal places for some kind of engineering application, yeah, you're probably going to use one of these 64-bit floating point numbers because that's the one that can do that. But if you're not, if you're fine with integers, you can keep those. And faster computations. Floating point computations are generally much, much slower than integer computations. Okay, especially if you're doing something like multiplication. Floating point numbers, it takes a little bit of, they seem really fast on the computer, but you can do a lot of integer multiplication in the time it takes to do one floating point computation. Okay, so there are different numbers. They have uses. Ta-da. Okay. So the four integer types, byte, short, int, and long. So byte is the smallest one, has 256 values, 8 bits. So each bit is a 1 or a 0. Bits for binary digit. So there's 2 to the 8th different possibilities there, which is 256. A short holds 16 bits, so there's 256 times 256, okay, 65,536. If you're old enough, when we're doing coding back when, you would remember these numbers because they were useful to keep in your head. 32 bits, right, is about a little over 4 billion possibilities, and 64 bits is a whole lot, right, a very large number. Okay, then there are two floating point types. There's a float, which is only 4 bytes long, and a double, which is 8 bytes long. Okay, the other two primitives, Boolean and char. Boolean is the true-false one. Char is generally a number that gets printed out as text. So you use it to hold text characters, but it is a number. Okay, so these are the 6 we got to know for now. 4 integer types and our 2 floating point types. Okay, so first, integer types. Every integer type stores an exact number in binary format, and each bit indicates a higher power of 2. The highest bit, the left bit, right, that indicates positive or negative in your standard Java formulation. So, for example, if we have this, I'm going to lift it straight from the slide. All right, well, I guess it's not cooperating. Oh, because I'm in white. Wait, what the hell's going on here? That's weird. No, it didn't like that. Okay. So, let's try this. Copying it in Notepad. That's why it doesn't work, because it's in... There we go. Yep. Okay. So if we have this kind of number in binary, right? This bit is a 128. Let's move that down. Okay. This one is 64. Okay, I'm going to draw another, I guess I'll draw the numbers. 16, 8, 4, 2, 1. Okay, so every binary digit is an increasing power of 2. Just like in our standard decimal notation, every digit to the left is an increasing power of 10, right? Same idea. So if we take all these numbers, 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that equals 127, right? That's how it gets that. this left bit, if we were doing what's called an unsigned integer that only went from 0 to the max number, this would count for 128. But in Java, these numbers are by default signed. They can contain negative or positive numbers. So if this last byte, if this becomes a 1, then this goes to the biggest negative number, right? Well, in this case, it's actually a smaller one. If we add 1 to it, let me say correctly what I wanted to do. If we add 1 to a byte equaling 127, it should go to 128. But in Java, it actually goes to negative 128 because the highest bit, right, the so-called 7th bit, goes to 1, and all the others go to 0, like so. Right? We see 1, 0, 0, 0, 0, 0, 0, 0. And this is still the bit that would be 128, right, down here. But instead, in Java, that says means it's a negative number. Okay? And it works that way for all the integer types, regardless of how many bytes they have. It's just, you know, this last byte will be a bigger one. So, anyway, if you have n bits, the total range of values is going to be negative 2 to the n minus 1 to 2 to the n minus 1 minus 1. So, for example, for a byte, right, with 256 values possible, highest is 127, lowest is negative 128, right? Which again, if you include the 0 in there, 128 negative values, 127 positive values, plus 0, add them all together, 256. Likewise, you know, for an int, about plus or minus 2 billion is about the number range you have. Okay? Now, this is not a math class, so I am not going to ask you to do these kind of binary computations. I'm not going to ask you, you know, what power of n is involved, stuff like that. But the reason why this is important is because if you have an integer number and you make it big by addition, you may actually flip around and make it negative, right? And so you need to be aware of that. Okay. For floating point types have an integer portion, right? What's to the left of the decimal point, and a decimal portion, what's to the right of the decimal point. Now, the actual encoding for that is sufficiently complicated. I don't keep it in my head, and I don't teach it. And I don't keep it in my head because I don't teach it. If you're interested, right, if you want to get your nerd on, you can go there and check out that link. It explains how it's done. But you absolutely do not need to know that for this course, right? Just recognize floating point number has an integer part, has a decimal part. Now, generally it's going to display a scientific notation, right? Once it gets beyond a particular range. So if you have 10, it'll display it as 10.0 because there's enough space to display it, right? But if you have a number like 6E27, it's going to go 6.0 E27. That's how Java displays doubles by default. Okay? So anytime you're dealing with a double, it'll always get printed out with the double portion, with the decimal point intact, even if the decimal portion is a 0. Okay? Just so you know, you're dealing with a double here, or a floating point. Now, floating point variables do store an exact number. But here's the problem. It may only approximate your target value. For example, how would you go about representing 1/3 in decimal? Is that an exact representation? It is not, right? No matter what your math people have taught you, okay? It is not precisely 1/3. It is infinitely close to 1/3, but it is not 1/3. And in a computer, we do not have an infinite number of decimal places, do we? We have, you know, about 8 for a float and about 17 for a double. Yes? No? Arm up. Okay. So, problem is, just like you can't represent 1/3 precisely in decimal, right? Especially with a finite number of digits, there are a lot of numbers you cannot represent precisely with this kind of encoding system in decimal. An easy one is in binary. An easy one is 1 divided by 7, right? You can't represent 1 divided by 3 in binary exactly either. So, okay, so the problem is floating point numbers, they're often really, really close to whatever thing you're trying to represent, but they're often not going to be exact, and you have to be careful about that. We'll talk about that when we talk about this kind of comparison statements. Okay, so quick summary of variables, all here in one handy slide. We have our byte, we have our short, we have an int, we have a long, we have a float, we have a double. Okay? Now, number ranges, bytes are useful for small numbers, right? For example, if you were, well, I don't know, if you had an application that tracked shoe sizes, for example, right, and you represented them on a simple number scale, yeah, that would cover it. Or say the height in inches of humans, right? Nobody's going to be more than 127 inches tall. That'd be okay, you could do that, okay? But a short, suppose you have a bigger number, right? Like you might have how fast a car can go, right? Most cars don't go above 127, but it is absolutely possible for a car to go that speed, right? So you would need a bigger number to hold that value. If you're talking about, I don't know, bank account size, it's theoretically possible somebody could have a bank account bigger than 2 billion. You're probably not ever going to meet that person. So you might have a banking application, that tracks it, using ints, or if you just track, the amount of dollars in a budget or something, you could reasonably display most things like that as ints. Okay? Long, however, tremendously large integers, right? Plus or minus 9 quintillion, so 10 to the 18th, a very big number, right? Usable even to cover things like our current federal debt, right? Our current federal debt is relatively small compared to this, just like about 20 trillion probably, give or take, okay? So a small fraction, almost, a millionth of this is how big a number that is. Floats are great, right? There's not a lot of numbers that you're going to use that are going to be bigger than that, right? So if you want to count how many atoms there are in a handful of some material, float ought to do that, right? The downside of a float is it only has about 8 decimal places. So if you're doing some kind of high precision engineering application, you might want more than that. But there aren't that many things where you would ever need to keep the integer part bigger than that. But suppose you did, right? A double is a number so ridiculously big that at its upper end of the range, I cannot actually think of any plausible real-world purpose for it. So, for example, the number of atoms in the universe is about 10 to the 80th, right? And this is way, 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 way bigger than that, right? So, again, I don't even know what you might possibly use a number that big for, but it's there if you need it. Okay, so these are your basic 6. Questions on any? Are we good? Yes.
Why did you use long in place of double if they take up the
Long in place of double because you need the decimal part. Long is an integer.
Right. Why would you use the integer if the double can represent that integer?
Oh, because it computes faster.
Okay. Even though they take the same amount of storage space?
Yeah, because basically there's this complex coding in for the double. Think about it, if you're doing multiplication, right, and there's a bunch of digits involved, it takes more time to do all those digits. Plus it has to, do some encoding to translate the number into some binary format to do the multiplication anyway. With a long, you get to skip that step, and that's why it's faster. Yeah?
So what does it mean by range? Like all around the way?
Minimum value to maximum value.
So like if it's like 128, like positive 128, what would that be classified under?
You could not store a positive 128 in a signed byte because it only has that range minus 28 to 127. You go up 1, a byte can't hold that. In fact, that is a perfectly valid thing to bring up. Let's demo it. Okay, so we're going to make a new class. Oop. Fun with numbers. Not very much fun, though. Some fun. Okay. If I have this, for example, I do byte b equals 128, I get an error. And it says here, type mismatch, cannot convert from int to byte. A 128 is sufficiently large that Java's by default going to think you want an int with that. If I make it 127, yeah, it's okay, can live with that, right? Because that can get stored in a byte. On the other hand, of course, if I do int I equals 128, that's perfectly fine. An int can hold a 128. But if I try to do a number way beyond that, like 3 billion, an int can't hold a number that big. It's only about plus or minus 2 billion for the range. I get the same error. It says here, the literal 3 billion of type int is out of range. It's effectively the same error, even though it's worded differently. Basically, this number cannot hold that value. Okay? This variable can't. Yes?
We are looking at bank account balance and the balance in some sense. Would we use integer or would we go to floating?
Well, it depends on how exact it has to be, right? You might very well use a double for that because, you know, even though with enough computations it could be off by a penny here or there, the fact that you're able to go out like 10 or 15 decimal places in practice means that no user is ever going to see that problem. Yeah. Probably use a double. However, there are additional classes for very large integers. You might just, you know, track that as an integer and then parse it to include the decimal part at the end. So instead of, say, holding a number of $10,000.50, you might hold, you know, yeah, all as an integer ending in 50. Yeah. Okay? All right, so we on board with this then? These are our variable types. Good. Any other questions? Okay. Now, variables can exist in two different ways. Number one, they can be a persistent object of some class, a persistent attribute of some class or object, which is called a data member or a field, right? So you can have data as part of a class, in which case, as long as the class is included in the program, that variable exists, or you can have it associated with an object, and as long as that object exists in your program, its associated data will also exist. Okay, so I can say either of two ways. I can give it static. What type should I make? Let's make it an int. Static int fwn int. Okay, that one exists for the class. Anytime I'm creating this fun with numbers, including this fun with numbers class, that exists. I could also make a couple of object ones. I just do int x and y. Okay, these ones exist with the object. Okay, so this variable is static and exists with the class. These variables are not static and are only associated with individual objects. Okay. Ta-da! That's your basic notation, right? Our basic syntax. Static for class stuff, otherwise that. You can also have them be local variables, right? So a local variable is, in a sense, a temporary value that's created for use in a specific method and becomes garbage after. Remember we talked about garbage collection? Data structures that you used once but you're no longer using? So, for example, you do something like this. Suppose, let's actually create a thing. So, fun with numbers, FWN, new fun with numbers. Okay? And fwn.run. No, let's do we'll do a compute. I'm going to import that. Damn it. It took a long time for that. Okay? Java.util.scanner. Okay, that's going to be able to read stuff in. So let's make a scanner. Yeah, we'll just do it in the run method. That's fine. Okay. So void run da-da. Okay, so I'll do int. I'll print out a prompt, system.out.println. Please enter a number. between 0 and 100. Okay? And then I'll say int x equals new scanner dot next int. Okay, that's going to read it. I'll comment this up in a second. Oh, system.in. Okay, and I'll do this again. Please enter a second number between 0 and 100. Okay, so I'll set that to y. And then okay, and then I'll print their product. Okay, so here we have a prompt. Prompt user to enter one number. Read it through scanner object and store in X. Okay, and the same thing for these two. Again, prompt the user to enter and store it in Y, and then display the product of X and Y. Okay, simple thing. Now this method will run, I create X, I create Y, I display the result. After the method ends, X and Y are gone, they're garbage, right? They exist only while this method runs. And every time somebody calls run, it creates new variables X and Y, and every time the method ends, they get discarded as garbage. Okay? All right, so for example, I could make some other method, like void do math, right? And X doesn't exist, right? If I try to do something after there, oh, it does because it exists in the, damn it, because it exists up there as an attribute. I could try to do, let's give these new numbers. FWN1 and FWN2. No, I'll keep those X as Y. Let's make this a different one. We'll do this A and B. I don't want to confuse you yet with this stuff. And we're going to multiply A and B. So A and B are local variables. If I try to say A is 2 down here, it doesn't know what A is, right? A cannot be resolved to a variable. That's because the scope of A and B is just this method. They only exist in here. Yes? Yeah? Yep. Oh, that is reading in data from the console. System.out is printing out to the console. System.in is getting user input through the console. So I type in something. Yeah. Not yet. No, but I mean, I got to do something interesting. I want to do it with user input. Yeah. You'll learn scanner before it's all over. It'll be easy. So again, I could run this. Let's verify if this works. It's pretty simple. I can't imagine it won't, but you never know. Okay, please enter. What's a number? I think I heard 50 first. What's another number? 30. So it should be 1500, right? Okay. Okay, so that's a quick thing with numbers. Let's move on. Now variables have to be declared and assigned a value before they can be used. So if it's a data member, if it's a field belonging to an object or class, it gets assigned a default value. If it's a floating point, it gets 0.0. If it's an integer type, it gets 0. So if you don't assign it any value, by default, that's what they get. However, even though that's standard Java policy, if you're a professional coder, you should not rely on that. You should actually assign them values as 0 because you never know what the future is going to hold, right? It is possible, however unlikely, that Java might change in that regard. Okay. Other quirk of Java, local variables don't get a default value. Local variables have to be assigned values. They don't have default values. So for example, I can do this. So I have X and Y and I didn't assign them a value. I can do fwn.x equals fwn.x times 3. And that's okay, because even though I haven't assigned the x attribute a value, it gets a default value of 0. Java knows that'll be safe. Okay? However, if I try to do that in a method here, if I say int z, and then I'll say z equals z times 3, it doesn't like that. I get the error. It says local variable z may not have been initialized. You have to initialize z with some value before you can use it if it's a local variable, if it's just confined to a single method. Okay? All right. So all this detail that I'm giving you, I know it probably seems like a lot, but when you start coding, this is important to know and understand so that when you find errors in your code, and you will, you understand what those errors mean and how to correct them. Okay? And these are things that come up all the time. Okay. Questions about that? Okay, moving on. So, declaration. Just like objects, variables are declared by giving them a type and a name. So you say int x or double z, whatever. Okay? So int x means that x is a variable of type int. Right? And double y means that y is the variable of type double. Style conventions, data members are the first statements inside a class, and usually alphabetically. Right? That's a little bit looser because most of these classes don't have all that many data members. So, you can have some flexibility. It's not like searching through a long list of 50 or 100 methods through a class where you really want to alphabetize them. And data members of the same type can be declared alphabetically on the same line. I mean, they don't have to be alphabetical, but we often do declare them on the same line, like I did in the code example. So, example, we have a class numbers. It has 2 doubles and 3 ints. So I could declare the doubles on the same line, double A, comma B. Remember I said commas are used for related things within a single, yeah. So basically this is equivalent to saying double A and a semicolon and then double B with a semicolon. I'm just grouping them together because there's the same kind of statement. Likewise, int x, comma y, comma z, same kind of thing. Java lets me group all them together to save space. And within a method, same thing. I have an int m. I can declare it by itself. Double n. I can declare it by itself. Okay? Easy, right? Yeah. Okay. Good. Now, unlike objects, primitives don't need to be created separately from their declaration. Okay? Once you create it, you can automatically assign a value. There's none of that new stuff. And the reason is, the primary reason is, if you create the variable, Java already knows, number one, knows how much space it's going to use. And number two, the amount of space it uses is not very big, right? So if you have an object and the object has several strings, well, potentially a string could be 2 billion bytes, right? It could be a very long number, or it could be a very large object, and could really mess stuff up. So maybe you don't want to do that right away. You don't want to reserve memory right away. But with these, 1, 2, 4, 8 bytes, I was going to just say, you know what, we're just going to go ahead and reserve that memory for it. So you don't need to create the new object before it exists. Instead, as soon as you declare it, Java makes a space for it in memory and says, this thing is here and it holds some value. Okay? Well, that's true for data members anyway. These other ones, local variables, you don't have a default value yet, but still, you never need to invoke the new command to create a new int. Okay? So instead, when you want to use a primitive, you just assign it a value. You can either assign it a literal number. Literal just means where you actually write out what the number is, like 0 or 6.2. You can assign it the value of another variable. For example, you could say, if you already have an int x, you could say int y equals x, or equals x times 2, something like that. So you can use another variable. You can use an arithmetic expression, right? So some long, complicated thing. If you have numbers for radius and pi, you could set some value, int circumference equals pi times r, right? There's a formula for a circumference. So arithmetic expression. And you could also use the value returned by a method. If you have some method that returns a value, you can call that method and assign the result to a variable. So, for example, let's make a new thing, right? So here we initially had run, but let's break up run a little bit. Let's make it a little more modular just for fun. So I'm going to have two things. So I'm going to have int x equals get int, okay? And I'm going to have int y equals get int. And then I'm going to have, well, I'm going to say fwn.get. I could do that as a static method. Let's do it as an object one, though. Okay. So let's make a get int method. So int, get int, and I'm just going to copy this stuff in here. I'll just say, whoop. Okay. So in our getInt method, this is what we're doing now. It's going to display that prompt, and it's going to return it. So this thing, right, new scanner, system.in, next.int, that was the method that we called to actually receive whatever the number the user types in. And whatever that quantity is, we just return it from the method. So if this method here, this line, line 13, I'm going to call fwn's getInt method. It's going to ask me to type in a number. It's going to return that number. I'm going to take that result, the int that this method returns, and assign it to x. Okay, and then I'm going to do that again for y. Now, instead of run, let's do calc product. Let's do, yeah, fine. Get product. And I'll send along two ints, int x, or int val1, int val2. Okay, and I'm just going to return those. Okay, now if I want to, I could display that. Okay, so I'll do int z equals, what is my problem here? Oh, I got to send on x and y. Okay. So here, it's nice and compact. X asks for a number, y asks for a number, z gets the product. I send along x and y as arguments to this method, receives them as parameters. I return their product. Change that comment. And then I print out the result. Okay, and this will do basically the same thing as before. So I can run it. Please enter a number, I don't know, 99, 98, 9702, okay, which is correct. Does this much make sense? Questions up to? Okay, so here we just have methods. Their return type is a number. So when we call the method, we ask it for something, it'll send back a value. Okay, that's all a return type is. And one of the most common, and really, I mean, I don't know why it happens. One of the most common student errors on exams is they mistake returning a method, returning a value for printing a value. Okay, so I'm going to put that in big letters in Paint so when people review, and put this. Let's put it in, I don't know, Cambria. Okay. Returning a value is when a method returns that value as its return type. Okay? Like int get number will return an int. Okay? Printing a value to the console is just calling the method system.out.println. Okay? And I'll say value. I'll italicize this. Okay? They are two different things. But there will be questions that ask you, write a method that returns blah, blah, blah. That means the return type for that method should be it. It has nothing to do with printing the value. If the method asks you to print something to the console, you do this. It's not the same as the method having a return type. Okay? I don't know. People mess that up. I don't know why, but it's common enough it's worth mentioning. Okay. And as we've seen, statement can include both declaration and assignment, right? You can wrap them up together. For example, like we do here, we have this, right? Int z equals fwn.getIn. So I'm declaring x on the left part of that, and on the right, I'm assigning it. I'm getting that value and assigning it to x. So you can do it all in one step. Same as you can declaration and creation with objects. You can do it in one line. Okay. So assignment examples. So again, this is numbers, has 2 doubles A and B and 3 ints. I can assign them separated by commas as well. If I want to automatically assign values to these data fields whenever I create a numbers object, I can do this. I can say double A equals 0.0, B equals negative 1.6. And anytime you create an object, it'll get those default values. Same way here, x equals 0, y equals 1, z equals 2. If I create a numbers object, it'll get assigned with those default values for those variables. Yeah? Okay. This all makes sense? Are we good? This is, yeah? No questions? Something? Okay. I'll do one more slide, then we'll call it a day. Maybe two. Maybe two. Yeah, I guess we'll do 2. Okay, because this one is kind of trivial. So, arithmetic expressions, of course, they're widely used, right? They use them for computations, use them for assignments. And there are 5 basic arithmetic operators in Java. 4 of them you know, the 5th you probably don't. So, plus for addition, minus for subtraction, asterisk or star for multiplication, depending on where you're accessing it on your keyboard. Okay? It's a star on my keyboard, but in many fonts it appears as an asterisk. In Java, in the IDE, it appears as an asterisk. Okay? / for division, and the % for modulo. What's modulo? Does anybody know what modulo is? Yes? That is for the remainder. Yeah. So modulo just means you run a division, and whatever the remainder is afterward, that's the modulo result. Okay. So the nice thing about modulo, why it has some practical benefit. Okay. So I'm not going to talk about the others in great detail. Modulo. I'm not going to be able to tell you. Is the remainder after a division operation. So, for example, int x equals 6, int y equals 4, x modulo 4 equals 2, because x divided by y equals 1 with remainder of 2. Yeah? That's what modulo is. And the nice thing about modulo bounds the range of the result to the numbers involved. So, let's stretch that out a bit. In this case, can never be larger than y, right? There's no way doing a modulo operation that you could have a value of 4 or greater, right? Because if you're dividing by something and the remainder was 4 or greater, you would just actually have one more whole thing in your division, so it always rounds down. So it's very useful if you want to, say, do some operation that ensures the final result is still contained within the space of whatever data structure you have. It's good for things like, like doing encryption and stuff like that, where you want to have the message not actually add any extra length, you just want to scramble the bits involved. Okay, so a lot of what goes on in encryption schemes is multiplication through modulo operations with very large prime numbers. Okay. Anyway, all right, so the basic syntax is this. The variable goes on the left, the actual expression goes on the right. So some variable, int x, double y, whatever, is equal to some expression. And in this sense, this is not an equality. This is not a statement that this equals that. This is a statement that says, whatever this is, I'm going to make the variable equal that, right? I'm going to assign it to that variable. So everything on the right has to be calculated first, and then that result, the final outcome of that set of calculations, gets assigned to the variable. Wouldn't make sense to do it otherwise, right? If you're saying x equals 6 times 3, you wouldn't say, well, okay, x equals 6, and now x equals 6 times 3. No, you just do the 6 by 3 first, and then you assign that result. Okay. Other thing, there are implicit operator assignments. So if you're talking about doing something to the variable itself, what you want to do often is do plus equals. So this one, x plus equals 1, that means x equals x plus 1. I'm assigning the value of x plus 1 to x. Likewise, x minus equals 2, I'm subtracting 2 from x. X times equals 3, I'm multiplying x by 3. X divided equals 4, I'm dividing x by 4. And x modulo equals 5, I'm modulo operating x by 5. Okay? All right. Last two things, increment and decrement. Double plus means you're adding 1 to it. Double minus means you're subtracting 1 from it. Right? And programmers just use these because they're lazy and, you know, this leaves more time to play Call of Duty or stuff. I don't know. Okay? Quick intro to numbers. Any questions on this? Any last lingering questions? Yes? Yeah. Yeah, there's always multiple ways to do stuff, right? So, depends on what you want to do. So I will give, right? Suppose you have some int x equals 6, and you want to increase it by 1. You could take the very long step. You could say, right, the shortest is just x plus plus, right? I add 1. You could also do x plus equals 1. You could also be complicated. You could say int y equals x plus 1, x equals y. You could do that. There's different ways to get through to the same destination. But generally, programmers take the quickest, most compact way. Yeah. Okay. Then this is a good break point.